Hello. For this video, we are going to investigate a trigonometric identity that we need to verify. This identity is 1 plus sine of A minus cosine of 2A over cosine of A plus sine of 2A, and it is equal to tangent of A. Now, if we take a look at this, we can see that the left side is more complicated than the right side. So it, oftentimes the process of verification is easier if you have to simplify a more complicated expression rather than having to convert a simpler expression into a more complicated expression. So therefore, it makes sense to verify by turning the left side into the right side. Now, another thing to note is that we have double angles in this particular expression and only a single angle in the expression that we're trying to convert to. This is a sign that we have to use the double angle formula. So there are two trig functions with double angles. They are sine and cosine. If we use the double angle formula for either one, we convert to an expression that has a single angle. So that way it becomes easier for us to get to our final results that also has a single angle. Now we may ask ourselves which formulas we should use. Well, for sine of 2a, there's just one formula. Sine of 2a is equal to 2 sine A cosine A. And yeah, so we know that we can just make a substitution here. So sine of 2a is equal to 2 sine A cosine A. But then for the cosine of 2a, we have three formulas to choose from. Of course, it is possible to convert each of these expressions into the other using another trigonometric identity. But however, just choosing one of these three forms may make it easier for us to simplify the expression. Now, if we consider that we already have sine A in the numerator, if we can keep the like all of the trig functions the same if possible, then it makes it easier for us to simplify because we can take advantage of properties of algebra more easily. So if this one here is sine of A, then we want to convert cosine of 2a into a trigonometric expression that just has sine, so that we have sine here and we have sine there. So that way we can just simplify it more easily. So basically we can use the cosine of 2a is equal to 1 minus 2 sine squared of a. So we're able to just make that substitution here. And then once we make that substitution, we can use algebra to simplify it. We can distribute the negative. And to do that, we can imagine that there's a -1 here. So we distribute the -1 like this. So we multiply -1 times 1. That gives us -1. And -1 times -2 sine squared of a, that gives us +2 sine squared of a. And then from here, we see that we can combine like terms because we have 1 and then -1. So these cancel out. So we're left with sine of a plus 2 sine squared of a. And yeah, so from here, since we're dealing with a sine in this particular term and a sine in this particular term, we can actually just factor out a sine of a. So we can put sine of a on the outside of the parentheses, And then on the inside of the parentheses, we just have to put um what we need to multiply to get back to the original. So we know that sine of A times 1 gets us back to sine of A, and sine of A times 2 sine of A gets us to 2 sine squared of A. So that means that we need to put 1 plus 2 sine squared of A. Yeah, so basically we can just multiply this back. Like we can distribute the sine of A back the into the parentheses to double check to see if we factored it correctly. All right. And then next, for the denominator, we can factor that as well. It looks like we have a cosine of A here and a cosine of A here, so we can factor out cosine of A. And then we have to ask ourselves, cosine of A times what gets back to cosine of A? Well, that's 1, so we put a 1 here. And cosine of A times what gets us to 2 sine A cosine A? Well, it's just 2 sine A. So it looks like we have cosine of A times 1 plus 2 sine of A. And once again, if we want to, we can check it to make sure we get back to the original. So that means that we have the correct factors. So now, since we have these two factors, which are essentially identical, we could just go ahead and just cancel them out. Um, so we end up with sine of A over cosine of A. And yeah, and we just need one more identity. So to turn sine of A over cosine of A into tangent of A, yeah, it's just like one particular identity that we need to consider. So tangent of A is equal to sine of A over cosine of A. So when you see sine of A over cosine of A, you get tangent of A. And that is how we can convert the left side into the right side.